the concept of this video is adding and subtracting polynomials. So maybe the first question you're asking yourself is, what is a polynomial? A polynomial is a kind of an expression, and it's with multiple terms, okay? And maybe you're asking yourself, well, what's a term? Well, a term can be lots of things. It could be a variable. It could be a constant, which a constant is a number. It could be a mix of the two. So it could be what we would call a monomial, okay, which is a mix of a number and a variable, okay? So something like 2x. It could be a variable squared. And so how do you know how many terms there are? Well, a term is separated by addition and subtraction signs. So you might have something like x squared plus 4x minus 7. Well, this is 3 terms. There's a term, here's a term, and here's a term, all separated by these addition and subtraction signs. So there are 3 terms here. And this would be known as a polynomial because there are multiple terms. Anything really more than 2, okay? Some other words that you might hear is like a binomial. Well, a binomial, remember from the word bi here, that means 2 terms. Okay, this monomial, mono means one term. And then the last one you might hear is a trinomial. And I'm hoping you're saying, well, tri means, you're right, 3. So, but a polynomial is just something to say, like as an overarching, okay? So we're going to be adding and subtracting polynomials, so we could have anywhere from 1, 2, 3, or even 4, 5, 6 terms if we want to that we're going to be adding and subtracting. We're going to stick with 2s and 3s right now, okay? So when you think about adding and subtracting polynomials, the adding is not so bad. Essentially, when you're adding polynomials, this is pretty much just combining like terms, which you've had for a long time. So that's essentially what this is. There will be parentheses around your polynomials, but if you're adding, you can drop the parentheses and just add, okay? For subtraction, that's a little bit different because you're subtracting an entire other quantity, which that quantity is written as an expression. So your process here is to distribute the negative and then combine like terms. And when I say distribute the negative, remember that it goes to all terms in the second parentheses. Okay, so now that we have these steps, let's give this a try. So here you can notice that I've got 2 polynomials. Polynomial 1 is here and polynomial 2 is in the back, and I'm adding them. So remember from the previous slide there, it said that I could just combine like terms. So you could do this multiple ways. Some people are able just to look at it. Some people do, you know, like, oh, I'm going to box these, and I'm going to circle these, and I'm going to do a triangle here. So you could do that, and then you just combine them, right? So this would be 12x squared plus 2x minus 2. So that's one way you could do it. Another way you could do it is by a table, right? I've got an x squared term, I've got an x term, and I've got a number term, right? So I've got 5 here and a 7 here, a 3 and a -1, and a -4 and a 2. And so when I add down, I get 12, 2, and -2, and then carry down your terms, right? So there's your x squared plus x and then 2. So essentially you can see that you get the same thing. No matter how you organize it, they both will work, okay? So here's what we're talking about, the subtraction, right? I've got 2 polynomials with a minus sign in the middle. So this is where I need to distribute the minus sign to the back half here. So I'm going to have 8x squared minus 6x minus 9x squared plus 4. So now is the point where I can combine like terms because I've taken this negative and I've distributed it to both, okay? So now is to the point where I can say, okay, my x squareds, I have an 8 and a -9, which is negative x squared. and a negative 6x and nothing, so negative 6x goes by itself, and a positive 4, which goes there, so here is my final. If you're a table person, I've got an x squared, I've got an x, and I've got a number. So when I fill this in, I've got 8 and negative 9, negative 6 and 4. So here you can see where there's nothing to combine other than the x squareds. So I have 2 examples left. I would encourage you maybe to push pause and try these on your own and then check your answers with mine. But I'm going to go ahead and solve these. So use your organization method that I think works best for you. I should also maybe mention that it's important. I always like to write the highest degree first, which is the largest exponent. So that's these squares. So I'm going to have 11b squared, and then plus 23b, and then minus 19. So this is the answer you should have gotten there. And for the last one, I'm going to take this negative and distribute it. Got to watch out for those minus negatives because they can get tricky if you don't pay attention. So minus 5 plus 11f because it was originally negative, and minus 7f squared. So when I combine my f squareds, I get negative 3f squared. I've got 2 f's. Ooh, that's a negative 7f and minus 2. So there's my final. So as always, I would recheck the steps here, try some of these examples, and if you have any questions, please come see me. Thanks.